Hello again. This video continues our discussion of Lesson 3-3 in your Math 104 textbook. I basically skipped over the information on page 135. Once you've watched this video, it may not be a bad idea to go back and read through that, but I think it'll make a lot more sense actually after you've seen some of the problems actually worked out. There are two types of problems here. Question 1 and 2 are one kind, and questions 3, 4, and 5 are the other kind. And I'm on page 136, if I didn't say that already. Let's take a look at question number 1. Number 1 asks us to give an example of two trinomials whose sum is 14. So there are infinitely many different possible answers to this. One of the kind of neat things, but also challenging things about a question like this is that everybody can come up with their own version of a correct answer. This is the process that I recommend you go through to do this. So what I'm going to do is note a couple of things in the instruction. Number one, that we are asked to give an example of two trinomials. So trinomials have three terms. I'm going to create space for three terms. I'm going to make a little gap and make space for three more terms. So trinomial is an important word because we need to create our polynomials as trinomials, three terms each. The sum, the word sum is also important. Sum implies an addition. So we're trying to write something that looks like this. And this is a good place to start. What should our answer look like? Then we can start to fill things in. What I recommend you do is always start from the right side of the trinomial. That is from the terms that have lowest degree. So at the very right hand side we typically have constants. In this case we need two numbers that add to 14. So I might choose something like 4 and 10. 4 plus 10 would give me the 14. Now that's all that my two trinomials have to add up to. That implies that any other terms are opposites of each other. So if we go from the constants, the 0 degree terms, the next terms as we move left would be first degree terms. That is, they'd have the variable x in them. So I might choose something like plus 2x in one and minus 2x in the other, because those will add to 0x, and that's what I have in the answer, 14. Same thing is going to be true for the next terms. In this case, we've gone from 0 degree to 1 degree. Now we're going to go to second degree terms. I could say something like minus x squared or minus 1x squared, plus 1x squared or 1x squared. Those are opposites, they'll add to 0. And now if you add these two things together, you should end up with 0x squared plus 0x plus 14, which is just 14. So there's one example. And again, lots of different ways to do this. There's infinitely many different ways to come up with 14 and to come up with the 0x and the 0x squareds. Number 2 is similar, but the two words we're going to look at here are the words binomial. So our polynomials are going to have two terms each, and the word difference. Difference means we're looking at a subtraction question. So our general layout is going to be a binomial minus another binomial. That's what we want it to look like. And the subtraction part can be a little tricky, so pay close attention to it as you're working on it. In this case, we want the answer to be 5x plus 2. So two numbers that add to 2, for instance, are 1 and 1. Now be careful with these. You never want to use 0 anywhere in these, because as soon as you use 0, like if I said that one of these was 0 and the other one was 2, the polynomial that has 0 is no longer going to be a binomial, because 0 doesn't count for a term. So always make sure that you're using non-zero values, non-zero coefficients when you're creating these things. The 5x, actually I just did that wrong, didn't I? So let me fix that. I added, which is really easy to do. I want two numbers whose subtraction is 2. So I could use, for instance, plus 4 and plus 2 here. 4 minus 2 would give me that positive 2. Still don't want to use zeros here, but I need to make sure I'm doing the subtraction and not the addition. And I could go back and remake this video. I'm going to leave that mistake in here though, because I think it's a good thing for you to see that it's a really easy mistake to make, to accidentally add instead of subtract. To get the 5x, we might do something as simple as 6x minus 1x, or just x. So if we did this, 6x minus x would give us our 5x, 4 minus 2 would give us our 2, we'd have 5x plus 2. Be really careful with the subtraction ones. All right, those are two different kinds of problems. The third type, we're solving an equation that has a polynomial in it. So when I write these down, I'm going to drop the parentheses, and I can do that because there's nothing in front of it, which means there's a positive 1 in front of it, which means if we multiplied by that positive 1, we would just get what was inside the parentheses when we remove them. So for all of these problems, I will rewrite them without the parentheses. We can drop them in this case because there's nothing in front of the parentheses. If there was something in front of the parentheses, a number or even just a negative sign, we'd have to worry about distributing in order to get rid of the parentheses. But the way these problems are set up, you don't have to. What we're trying to do in each one of these things is solve the equation for the capital P. So one of our tools for solving, we can, for instance, subtract 3x from both sides. That'll leave me with negative 2 plus p is equal to 4x plus 5. And then I can add 2 to both sides, and I'll end up with p is equal to 4x plus 7. And what we basically said is if you take the polynomial 3x minus 2 and add the polynomial 4x plus 7 to it, you will end up with the polynomial 7x plus 5. So instead of having to find the answer, we've been able to find the one of the two polynomials that we were adding together. I'm going to scroll my page up a little bit here to make a little more room. Number 4 will work very similarly. We have x squared plus 12x minus 24 plus some polynomial p is equal to minus 4x to the 5th plus 9x plus 2. If I subtract x squared from both sides, notice that when I do this on the right-hand side, there are no x to the second power terms, so I can't combine it with anything. So I'm just going to end up with minus 4x to the 5th minus x squared plus 9x plus 2. I'm going to go from 3 terms to 4 terms on the right because there are no like terms to combine the x to the second power term with. I'm going to continue. Subtracting 12x from both sides, now I have negative 24 is equal to p, plus p, excuse me, is equal to negative 4x to the 5th minus x squared. Here I can combine like terms. We're going to end up with minus 3x plus 2. And finally, we'll add 24 to both sides. And we'll end up with p is equal to negative 4x to the 5th minus x to the 2nd minus 3x plus 26. And if you add the original polynomial, x squared plus 12x minus 24, to your answer, you should end up with the polynomial we see on the right, negative 4x to the 5th plus 9x plus 2. I'll show you a slightly quicker way to deal with these in the last one. Number 5, we have 4x squared minus 6x plus 10 plus p is equal to, and 17. So if you're comfortable doing this, you're welcome to try this method. We can do minus 4x squared from both sides. At the same time, we can do plus 6x to both sides. And at the same time, we can do minus 10 to both sides. And with p is equal to minus 4x squared plus 6x plus 7. The only like terms to combine on the right-hand side are the 17 and the negative 10. They're both constants, so they'll combine. And you can check yourself. Go back and take 4x squared minus 6x plus 10, add negative 4x squared plus 6x plus 7 to it, and you should end up with exactly 17.